Hello everyone, today we're going over 2.6 transformations of functions. So I'm going to give a review first of all. Last time we spoke about vertical stretching and shrinking of graphs. So I said to graph a function like this, y equals c times f of x, such that c is a real number greater than 0, but is not equal to 1. If this c is greater than 1, so we're going to do stretching of the original function y equal f of x without the c. We do stretching of the function vertically, but if this c is between 0 and 1, like 1/2, 1/3, 1/4, any number between 0 and 1, we're going to do shrinking to the function, to the original function y equal f of x vertically. Also, I spoke about horizontal stretching and shrinking of graphs. I said here between the horizontal and vertical, the c, in the vertical, the c is outside the function, as we see here. But for the horizontal, the c, the number is inside the function. I mean, inside the function is inside the parentheses of the function. If this c is between 0 and 1, so we're going to do stretching of the original function y equal f of x horizontally. But if this c is greater than 1, we're going to do shrinking to the function y equal f of x horizontally. Okay, and also I gave some examples last time for these two things, the blue one and the red one. Okay, today we're going over the even, and like the last things in this section is the even and the odd function. I'm going to define what is the mean of the even function and what is the odd function, and also I'm going to give examples how we can determine the function is even or is odd. So here even and odd functions. I'm going to do it in the next slide for the even and the odd function. So here, even and odd functions or function. So first of all, what is the meaning of even function? Do you know someone has the definition or know what is the even function? Anyone know what is the meaning of even function or hear about this concept before? Did you hear about this concept, even function, before?
Yes.
What is the meaning of even? Can you define it or give me any idea about even function?
It's
Okay,
a
it's fine. I'm
function.
going to go ahead, Aziza.
It's a function if f of x is equal to f of negative x for all values of x.
Okay, perfect, nice. It's a function such that f of x equal f of minus x for all x from the domain. This is nice. And did you hear about the odd function too?
Yeah, I heard about it.
What is the mean of odd function? Or can you define it the same as the even?
It's functions that return their negative inverse when x is replaced with negative x.
Again, can you repeat what you said?
I said that it's a function that returns their negative inverse when x is replaced with negative x. It means that f of x is an odd function when f of negative x equals negative f of x.
Okay, nice. Yes, this is correct too. Yes. So thank you, Aziza. So suppose let f be a function. So we said the f is even function if that satisfying. So here, so f is even function. We said f is even if f of x equal f of minus x for all x for all x in the domain of the function f. So f is even function if f of x equal f of minus x for all x in the domain. So we have to check if the function f of x equal the f of minus x. So we're going to say the function f is even function. The same things for the odd. We say the function is odd function if satisfying, like here, function is odd function if the function f of x equal f of x equal minus f of minus x, or like Aziza said, minus f of x equal f of minus x. Both of them correct. So we can check f of x equal the minus of f of minus x, or we can say minus f of x equal f of minus x. Both of them correct. But I like this form because it's easier to check the function and it's faster to check the function when you're doing this one. I'm going to explain or more about this by the examples below. So my example, suppose the function. So here example. Determine which of the following functions is even or odd or neither even nor odd. Even nor odd. So I'm going to give you some some functions, and we're going to determine if this function are even or odd or neither even nor odd. So suppose for the first one, number one here, here's number one, my function f of x equal x cubed plus x. For the second one, g of x equal 1 minus x squared. And for the third one, h of x equal 2x minus x squared. Okay, who will do the first one? In the beginning, I'm going to do the first one, and someone will do the second one and third one. So for the first one, to check the function is even, Anta said the first one is odd. How you know this? How did you know this? Can you explain how you know? How did you know this? Like this, because of the exponent. Oh, okay. Cube. Actually, this is not correct. I see a lot of students, they have the same idea. They said Here the exponent is odd, and here is the exponent is odd, so the function is odd function, and this is completely wrong. This is not correct. If you're doing this in the exam, you will get like a wrong answer, because sometimes the function is even function, even it has like odd exponent. Not because the exponent is odd here and the exponent is odd, so the function is odd function. This is not correct. So to check the function is odd or even, you have to use these rules, number 1 and number 2. That's why a lot of students they get wrong in the exam when solving some question like this. So for the first one, let's checking. You have to write f of x equal x cubed plus x, and you have to write here f of minus x. This is mean you have to plug the minus inside the function. So here I get minus x to the power 3 plus minus x. And this is equal minus x to the power 3 is minus x cubed. Why? Because minus x times minus x times minus x, I get minus times minus is positive. Positive times negative is negative. And x times x times x is x cubed. So here I get minus x cubed plus minus, so we'll get minus x. Now for the third one is minus f of minus x. You have to write the first one, second one, third one. Third one is the same like the second one, but we have to multiply it by minus. So you put minus, open parentheses, and you copy this one here. You copy this one, and you put it inside the parentheses. I get minus x cubed minus x. Now you distribute the minus inside the parentheses. Minus times minus is positive. Positive x cubed minus times minus is positive x. Now you have to comparing the first one with the second one and the first one with the third one to check if the function is even or odd. So when you compare the first one with the second one, you check the function is even, because the function will be even if f of x equal f of minus x. So the first one and the second one, you have to check if they are equal. To check the function is odd, you have to check the first one, this function, with the third one. So for the first one, let's me check here. So again, you have to check this one with this to check if the function is even, or you can check this one with this with the third one to check if the function is odd. Okay. So is f of x equal to f of minus x? F of x is x cubed plus x, and f of minus x is minus x cubed minus x. So they are not equal. So the answer is no. This is mean the function is not even. Now you have to ask yourself the second question. Is f of x equal to f of to minus f of x minus x? Is this one equal to this one? X cubed
Yes.
plus x? Yes. So the answer is yes. So this is mean the function is odd. Here, the function is odd function. So is it yes, the function The function is odd. It's odd. Yeah, Laila, this is correct. The first one and the third one are correct, are equal, so the function is odd. About the first one? Now for the second one, who would do the second one? G of x equal 1 minus x squared. Second one, G of x equal 1 minus x squared. Who will do the G of minus x? Who will do the minus G of minus x? Who will do the
I
G
could try
minus?
doing that one.
Okay, let's do it.
So if I'm correct, you put minus parentheses, 1.
Okay.
No. That's the x. Yeah. I think that's what it was.
Yeah, just plug this one.
Yeah, it's only for that one.
Yeah, go
so
ahead.
It's 1.
Okay. Minus.
Parentheses.
Open bracket. Okay.
Yeah.
Of x.
Yeah, and then to the power 2.
Exactly. So what does that equal? You have to simplify.
That would be 1
minus
x to the power of 2, if I'm correct.
Exactly. Nice. Correct. Now for the third one, who will do the third one? We have to put minus. Then what we should to do?
You would plug in 1 minus x squared.
Exactly. So you open parentheses, you put 1 minus x squared. You copy this thing here. Because this is minus g of minus x, this thing. What are you going to get here?
It's going to be -1 plus x squared.
Exactly. Now you have to check, is g of x equal g of minus x? Is g of x equal g of minus x? Is it equal?
Yes.
Yes. So the function is
Even?
Is even. Yes. And you stop. So the function is even. Okay, now the third one. The third one is h of x equal 2x minus x squared. H of x equal 2x minus x squared. Okay, you have to check h of minus x and minus second one. Just plug the minus inside this function. Any volunteer? Bilal, would you like to do it?
Will it be 2x minus 2x?
2x minus 2x, like this?
No. 2x minus parentheses negative x squared.
Negative x squared. But what about this x? You did not plug the minus inside this x.
All right, yeah.
So what's it supposed to be like
The
this?
2 parentheses, yeah.
Yes, okay. So 2 times minus x squared. Because actually, if I want to rewrite these things here, it's equal to open parentheses x minus open parentheses x squared. And inside the parentheses, you plug this thing here, the minus x. So again, Bilal said here we can plug the minus, so I'm going to get 2 times minus x minus open parentheses x square. Minus x square, sorry. So minus x square. Here minus x square. Okay, let's simplifying this thing here. 2 times minus x, they give me
minus 2x.
Yeah, go ahead.
Minus
Bilal.
2x, and then
Okay.
plus minus x squared. Right?
Exactly, this is correct. Nice. Now who will do this? The third one, minus h of minus x. Just multiply this thing here by minus. It's not hard. We'll do it.
I could do it.
Okay, go ahead.
Okay, so it will be negative, yeah, parentheses, and then we
Okay.
put everything inside. Yeah.
Okay. And
And
what
then
you're
after
going to
that, it's going to look like 2x
get? 2x.
plus 2 to the power, x to the power of 2.
Exactly. Nice. Now you're going to ask yourself the same question. Is this function h of x is equal to this function h of minus x? Is this equal to this? If you're looking
No.
here 2x minus x squared and here minus 2x, so the answer is no, it's not equal. So the function is not even. Function is not even. Okay, for the second question, is h of h of x, sorry, equal to the h minus h of minus x? Is this thing here equal to this?
No, isn't
No.
it? Because it's a negative and then there's also positive.
Exactly. Here, if we see here is negative 2x negative x squared, but here 2x plus x squared. So the answer is no. So the function also is not odd. Function.
So identified, unidentified?
So the function is not even, is not odd. It's not odd. So the function is neither even nor odd. Okay? So it's not even and it's not odd. Okay, any question for this?
So your answer would have been neither? That's
Yes.
the only thing you read?
Yes.
Okay.
Yeah. So neither odd, yep, is neither even nor odd. It's not even, it's not odd in the same time. Any question? So by the even and odd function, here we finish this section. So this section is finished. Now let's go to the next. Okay, 2.7 is combining functions. Here, 2.7, combining functions. Okay. I'm going to define two functions, f and g, such that these two functions, they have different domains. So I'm going to say here, suppose I have a function, let f be, let f with the domain. So f is a function, so let f with domain a. So f has is a function with domain a, a domain, and let be a function, and at the same time let the function g with domain b be a function, be the second function. The g with domain b be another function. So by these two functions, f and g, I can define some rules. First one, so number one, f, open parentheses like this, f plus g of x, this is equal f of x plus g of x. So again, suppose I have two functions. The first function is the f function, such that the domain of this function is a. And the second function is g with domain b. So I can, adding these two functions, this is called the sum of these two functions, f plus g of x. We can define it as f of x plus g of x. But the important thing here, we have to know the domain of the sum. So the domain of this function, the domain of this function, so the domain is a intersect b. The common value between a and between the set a and the set b, or between the domain of the first function and the domain of the second function g. So the domain of the function f plus g is the intersection between the both of the domains f and g. This is the first rule. Second rule, we have to know, number two, the difference between the two functions f and g. So I can define f minus g of the function x. This is going to be f of x minus g of x. And again, the domain, the same things. The domain of the difference between the two functions is the same thing. So the domain is the intersection A intersect B. Okay? The third function is the product. So the product between the function f times g, two function, if we multiply the both of the function f times g of the function of x, this is going to equal f of x times the second function g of x. And again, the domain of the product between the two functions, the domain is the same as before. The domain is the intersection between the set A intersect the set B. The last one, number four. So the quotient. So suppose I have the quotient, mean the dividing f by the second function is g of x. This is equal to the f of x over, this is equal f of x over g of x, such that, or I can write it as f of x times the reciprocal for the second one, 1 over g of x. Both of them correct. But the domain here is different. So the domain will be the same like before, but we have to remove the zeros from the denominator function. The denominator function here is g of x. We have to remove the zeros of the function g of x. So the domain here is any value belong to the intersect, x belong to the intersect, a intersect b, but we have to remove the zero of the function g of x because g of x is the function in the denominator. We have to remove the zeros of the denominator, not equal 0. Any question for the fourth from 1 to 4? Okay, if no question, I'm going to give example. So the example is, so let the function f of x, suppose I have function f of x equal 1 over x minus 3, like this, 1 minus over x minus 3. And I have the second function is g of x. G of x is the square root of x. So I have one thing here, find f plus g of x with the domain. Who will applying this rules from the first rule here? Who will do this example by applying the first rule? What is that equal by using the first rule? Look here. It's direct. Anyone can do it?
So you're talking about like the example?
Yeah, I'm talking about the example. So I have f of x equal this. I have the g of x equal this. The question is find f plus g of x, like this. Find this one. So as I know here, as I see here, f plus g of x equal f of x plus g of x. So
my question is, would
yes, go ahead.
x be the fx one?
Yes, so f plus g of x equal f of x plus g of x. Can you plug the function here?
I mean, from the example, it would be 1. I mean, it will be 1 over x minus 3 plus.
Okay.
I mean, you will put a parenthesis,
Plus.
I guess. Yeah, and then it will be
No, we don't have.
Oh, okay, and there would be to the root of x, if I'm correct. If I'm
Yes, x
yeah.
square root. This is correct. Thank you. This is correct. Just plug the function instead of this. So f plus g of x, you have to write the rule is f of x plus g of x. Now f of x is given, look, equal 1 over x minus 3. And g of x also is given. So it's the square root of x. Just you plug it instead of g of x. So this is equal 1 over x minus 3 plus g of minus square root of x. Now the second part asks about the domain of the function. So the domain of the function, I mean the domain of f plus g is the same as the intersection between the both of the domains. Is the intersection between the domain of the function f intersect the domain of the function g. So let's do it together. So what is the domain here? The domain of the function f of x equal 1 over x minus 3. What is the domain of this function? What is the domain of the function f of x equal 1 over x minus 3? What element I cannot plug inside this function? Here you go, Jennifer. Again, what is the domain of this function? F of x equal 1 over x minus 3.
Can't you plug anything like infinity?
Any numbers can I plug inside this function?
I think so.
What about the 3?
No, you can't plug into.
Can I plug the 3 here inside this function?
Oh yeah,
Check.
no, because then it would be 1 over 0.
Exactly. So I can plug every number inside this function, but I cannot plug
Except
the 3.
3.
Except 3, exactly. So for this one here, I can say the domain of this one is x such that x not equal 3. Why? Because we have to remove the zeros of the denominator. So now if I want to represent that in the real line numbers, so it will be like this. So it will be all numbers except the 3. Here is the 3. This is number 3. And all numbers will be in the domain. So like this. This is my domain. All numbers is in the domain except the number 3 is open circle, is not included. Okay. So at 3 should be open circle. It's not including the 3 number. 3 is not including. Now for the second function, the domain of the second function, domain of the second function is g of x. G of x equal the square root of x.
That means that every number except negative numbers can be plugged in.
Yes, exactly. So I can plug the 0 here.
I think you can. Wait.
You can.
Can I plug
Yeah,
the
because
0
it would be equal
for
to
this
1.
function? Now, what's the square root of 0?
0.
Square root of 0. What is it? 0, exactly. So I can plug the 0. I can plug any positive number, but I cannot plug negative number. So here I can say x such that x is greater than or equal 0. This is the domain. Now I have to represent that on the real line. On the real line numbers like this. So at 0, starting from the 0, here is 3, here is the 0, for example. The 0 is including, so close circle, and all numbers greater than this number, greater than 0. So all numbers greater than 0 is including in the domain of the g of x, like this. Now, I'm going to looking for the domain of the both of the function, the sum of the both of the function. So now my goal is to find the domain of, now the domain of the function f plus g of x. Now, as I know here from the beginning, is the intersection between the both of the domains. So I'm going to looking for the intersect between both of the domains. Here is my real line. As I see here, the intersect between the both of the line is starting from the 0. So here at 0, like this. But at number 3 is open. We have a problem here at number 3. And all numbers are intersect between both of the lines. Between both of the lines. So starting from the 0 is including. And all numbers is including, look. But at 3 is open circle. And here everything is including because 3 is open, is not including the first domain, but is including for the second domain. So we have to keep it open. And all numbers above the 3 is including. So I can write it as, graph it like this. All numbers greater than 3. And all numbers starting from the 0. So the domain should be like this. Domain here, domain 4. F plus g of x equal, starting from the 0, x is greater than or equal 0, and in the same time, x not equal 3. Why? Because the 3 is not including inside the domain. Any question? So this is the domain actually for the function f, the sum of the functions f and g is x such that x is greater than or equal 0 and x not equal to the number 3. By the way, this number here is 0. Here is 0. Okay. So I have another part of this question. The question now is find f plus g of 4. For the same question, I have part B. This is part A. This is A. Now B, find f plus g for the function at 4. So before we doing this one, I know f plus g of x is equal from the previous slide equal 1 over x minus 3 plus square root of x equal 1 over x minus 3 plus the square root of x. Now, who will plug 4 inside this function and give me the answer? You should to plug the 4 inside this function and give me the answer. What's the answer?
The answer would be 3.
Just
Yeah.
3. How you do this one?
Well, first you plug
1
in.
over what?
It would be 1 over 4 minus 3.
Okay. Then
plus square
what?
root of 4.
Okay, nice. And 1 over 4 minus 3 is equal what?
1 over 1, which is equal to 1.
1. Okay, nice. And the square root of 4 is?
2.
2. 1 plus 2 is?
3.
3. Thank you so much. This is correct. So just you have to plug the 4 inside this function, the black one, and you will get the same, you will get the answer. It's direct. Okay, now let's go to the second part of this section is composition of function. So here, composition of functions. Composition of functions. Okay, so we have two functions. Suppose I have two functions here. We have two functions. The first one f and the second one is g, f and g. The composition or the composite f circle g is defined by, I'm going to define it down. So here I have f circle g, or f after g, whatever you say, or f composite by g. So f and g, the composite function f circle g is defined as like this: f circle g this is equal f of g of x this is equal f of g of x. So f circle g of x equal f of g of x. So let me give you example how we can use this function. This is a new function here. Example, suppose I have two functions. The first function f of x equal 4x minus 2, and the second function g of x equal 5 minus x squared. I have two functions. Five minus x squared. So my question now, find f circle g of x, and after that, and find the opposite g circle f of x. Okay, who will do the first one? Just apply this formula. Who will do the first one? F circle g of x. What is that equal? As we see here, the formula is f of g of x, but I need someone to plug the function g of x inside the parentheses. So we're going to plug the function g of x inside f. We're going to put here the function g of x. My g of x is 5 minus x squared. This is my g of x. We're going to plug this function inside the function f. Now this is equal f of 5 minus x squared, like this. Now we're going to plug this function inside the function f. Inside this function, we're going to get here 4 times, instead of x is 5 minus x squared minus 2. Minus 2. Now we should to distribute the 4 inside the parentheses, and then we have to subtract it by 2. 4 times 5, they give me 20. 4 times x minus x squared is minus 4x squared. And we have here minus 2. This is equal 4 minus 20 minus 2 is 18 minus 4x squared. Any question for the first one? Is it clear how we did this thing? Again, f circle g of x, this is equal f of g of x. Now, g of x is the function 5 minus x squared. Just we have to put this function inside the function instead of g of x. Now, this is like a one piece. We should, like one block, we have to put it inside the function here, f of x, but instead of x, we're going to put this 5 minus x squared. Okay, let's do it here. 4 times 5 minus x squared minus 2. Here we have to distribute the 4 inside the parentheses, the first step. Then we have to subtract it by 2. So 4 times 5 give me 20. 4 times minus x squared, they give me minus 4x squared. And we have the minus 2. We put it outside. Now 20 minus 2 is 18. 20 minus 2 is 18. And we have here minus 4x squared. We get 18 minus 4x squared. Okay, for the second one, g circle f of x. So before I start doing the second one, I have to write the first one, f circle of g of x equal 18 minus 4x squared. Okay, now for the second function, g circle f of x. Who will do this first? Who will do this one? G circle f of x.
Can I do it?
Yes, go ahead.
Okay, so it's going to be 5 minus, and then parentheses.
Hold on, g
Four
of
of
f of x. So you're going to plug the function f, right? Inside the function.
Yeah.
What is the function f? Is 5.
The function of g of x is 5 minus, and then you would do parentheses, and then you would do f of x, which is 4x minus 2.
Okay, let's do it step by step. What is the function f here? We have to plug the function f inside the g. What is the function f?
F would be 4x minus 2.
Yes, 4x minus 2. Hold on 1 second. 4x. Here is 4x minus 2. 4x minus 2. Okay, then what we should do?
You have to plug g of x on the outside.
Okay.
It would be 5 minus, and then f of x, which is 4x minus 2.
5 minus 4x minus 2. Okay.
And then squared, since the x was
Square. Exactly.
Yeah.
Here we have square. Yes. Square. So we have to put the square.
And now you would just simplify.
Okay. Now, do you know how to simplify this thing here inside the parentheses?
Yeah, wouldn't you need to distribute the exponent to what's in the parentheses first?
Okay.
So,
how we can
4x.
simplify 4x squared? How much?
Yeah, so 4x squared, that would be 16x, I believe.
16x squared.
X squared,
Okay.
yeah. And then it would be negative, and then 4, since 2 squared is 4.
Yeah, we have negative 2 square is positive 2. Then negative what? We multiply this by this times 2. Do you remember? We multiply this term by 2. Okay, let's doing 2 times negative 2 is 2 times 2 is 4. 4 times 4 is 16x. Or if student they doesn't know what is how we can like the formula for the square, something like this, we can like multiplying this. So 4x square x minus 2 square, this is equal 4x minus 2 times 4x minus 2. So as Chris he said, we can multiply 4x with everything inside the parentheses, then multiplying this by everything inside the parentheses. So actually this is equal 4x times 4x is 16x squared. 4x times minus 2 is minus 4x. Minus 2 times 4x is minus here to hold on, here we have 8. Again, minus 2 times 4x is minus 8x, and minus 2 times minus 2 is positive 4. So I can get here 16x squared minus 8 is minus 16x plus 4. Here, sorry, here this is 4 here because minus 2 square is 4. So here is 4. So I get the same answer. Look, 16x squared, same here, plus 4. We have the same thing here, plus 4, and minus 16x. Here I get minus 16x. So now we have to multiply the minus inside the parentheses. Anyone can do this thing? We multiply the minus inside the parentheses.
I'll do
It's
it.
going to be negative.
Go ahead.
No, you can do it.
All right, so 5 minus 16x squared
Minus 16x squared.
minus
Okay.
4
Minus 4, okay.
plus 16x.
Plus 16x, correct. So we get minus 16x squared. Now let's simplify this here. We have here positive 5, negative 4. So minus 16x squared plus 16x, positive 5, negative 4 is positive 1. And this is the final answer. Now look, is this thing equal to the, is g of circle f of x equal to the f circle g of x? Is this thing equal to this one? Again, my question is f circle g of x is the same as g circle f of x?
No.
The answer is no. As we see here, is not correct that f circle g is not the same as g circle f. So I can here write f circle g of x is not the same as g circle f of x. Is not the same. Any question for this one? Any question? Okay. So now I have another example, but right now I'm going to give example by using numbers instead of the variable x. So my example is, suppose I have two functions, f of x. Let f of x equal 2x minus 4, and my second function g of x equal 3 minus x squared. So my question now, number one, find f circle f of 2. Number two, find f circle, g circle g of 3. Number three, find f circle g of 1. And number four, f, that's it, just only 3. Okay, who will do the first one? F circle f of 2. You have to write the formula first, then you plug the 2 inside the function. Okay, let me simplify it for you for like f of 2. Now, who will do this one? It's easy now.
I could try.
Go ahead.
It will be 2 parentheses 2 again.
So this is again f of 2 inside this function.
Yeah, so
2 times, okay,
2 minus 4.
2 parentheses 2 minus 4. Okay, what's the answer? F of what?
0.
0, correct. Then you plug the 0 inside the function again. Inside the function f.
Yeah, so it'll be 2 parentheses 0 minus 4.
Correct. And what is the answer?
Negative 4.
Negative 4. Nice. For the second one, g circle g of 3. Again, I'm going to simplify it as g of 3. Same like before. We have the g function. Here's my g function. Any volunteer?
It's going to be g parentheses 3 minus 3 squared.
3 minus 3 squared. This is correct. Can you simplify inside the parentheses?
That'll be 3 minus 9.
Okay.
Which will be g of negative 6.
Nice. Then?
And then you plug in negative 6 in the same equation.
Same. Okay. What are you going to get? 3 minus
you
what?
get 3 minus negative 6 squared.
Okay. What is
That'll
that?
be negative 36.
3 minus 36. Okay.
Negative 33.
So negative 33. Correct. Nice. Who will do the last one? F circle g of 1. F circle G of 1. Who will do this one?
You'll do F parentheses of 3 minus 1 squared.
G of 1, yes. So this is equal F of G of 1. You have to plug the 1. 3 minus 1 squared. Okay. What is that
That'll
equal?
be F parentheses 3 minus 1.
3 minus 1 is equal
2.
2.
And then
Okay,
you plug in 2 and F of X.
of the function F here. Okay, what
And
do
then
you
it'll
going
be
to get?
2 times 2 minus 4.
2 times what? Okay, nice. And what is the answer?
0.
0, correct. Because 2 times 2 is 4, 4 minus 4 is equal 0. So the answer is 0. Nice, thank you. Any question about this example? Everything is clear here. So you believe so. Do you have any question you confuse inside this example, Leila? Okay, nice. So now let's go. This is the section for 2.8. This is what we should to know about 2.8. We have to know the sum between two functions, the difference, the product between two functions, and the quotient. We should to know how we can adding two functions. We should also to know what is the domain of the function when we add two functions. Also, we should to know if the function asks me the sum between two functions for number, you have to know how to plug the number inside the function. Okay, and the second part of this section is the composition function. We talk about how we define the composition function f circle g of x equal f of g of x. I gave example for variable. This is the first example for variable. And I said here I can realize f circle g of x is not equal the opposite g circle f of x. And also I give example by number, and this is what you should to know about this section. Now for the next section, 2.8, here section 2.8, one-to-one function, one-to-one functions and their inverse. Their inverses. Okay, in this section we're going to talk about the function one-to-one and the inverse of this function, because it's one-to-one, so we can find the inverse of the function. First of all, I'm going to give I'm going to explain what is the mean of the one-to-one function. So here I'm going to start talking about one-to-one function, and then after I define the one-to-one function and we know which function is one-to-one, I will going to define the inverse, or we're going to find the inverse of the function of the function of the one-to-one function. So one-to-one function. So first of all, I'm going to define the one-to-one function. Anyone know any idea about one-to-one function from high school or can you talk about a little bit about what is the mean of one-to-one? Or did you hear about this definition before, one-to-one function? Like, do you hear about this before in high school or outside the math 190? What is the mean of one-to-one? No? Okay, it's fine. So one-to-one function mean every element on the domain so the domain, what is the mean of domain? So the domain, I'm going to like review what is the mean of domain. The domain is the set, the possible input of the function. So before I said the function is like a machine, right? So the possible input of the function is called the domain. The element, I can plug it inside the function and they give me defined function without any issue or without any problem. So every elements here, element on the domain takes different element on the range. This is what I mean of the one-to-one function. So every element on the domain of the function in the domain, like every element on the domain should take different element on the range. So I'm going to give like easy and simple example to explain what I said here exactly. So suppose I have a function. Suppose I have two functions. So this is the first function. Here is the domain. The domain is like a small set. Function, and I have another function. Okay, like this. Okay, for the second. So I have two functions. The first function has input is the set A. Suppose this is my set A here. Suppose this is A. And suppose this is my set B. Again, this is my set A. And this is my set B. So my function here, I'm going to call it the function f of x. This is f. And here I'm going to call it g, the function g. Here inside this set here, this set is called the domain of the function. This set here is called the domain of the function. Suppose I have the element 1, 2, 3, and I have 4. Also in this here, I have 20, I have 30, I have 60, and I have here 70. Same things here, I have 1, 2, 3, also I have 4. And the second set, I have 10, I have 20, I have 30. So for the first function, suppose the one here, suppose the diagram of the function, this here goes 30, this goes to 3 goes to 60, and 4 goes to 70, and the 2 goes to 20. For the first one here, for the second function, this is goes to 20, 2 goes to 3 goes to 30, Here goes to 20 and this goes to 10. Okay, now let's check the element inside the set A where exactly goes to the set, to which element goes to the set B. So as I see here, the 1 goes to where? To 30. The 2 goes to 20. 3 goes to 60. And 4 goes to 70. Where is the 1 goes to? Where is the 1 here goes to? 20, correct? The 2? 10, correct? 3? 3 goes to where? 30. And the 4? 20. So my question here for the first function f, see the function f, is every element, look to the definition, one-to-one function, every element on the domain takes different element on the range. So my question here, is every element on the domain, like 1, 2, 3, 4, takes different element on the range? As we see here, 1 takes 30, 2 takes 20, 3 takes 60, and 4 takes 70. Is the range different?
Yes.
Yes, look, the 1 takes 30, 2 takes 20, 3 takes 60, 4 takes 70. So every element in the set A takes different element in the set B. It's not the same element. So this is mean the function f is one-to-one. Because if every element in the set A takes different element in the set B, so the function f, so the function A is one-to-one function. Now look to the second one, the second function, the g function. Is it one-to-one? Ryan said no, because 1 and 4 goes to 20. Exactly. If you go in here, 1 takes 20. Okay, no problem. 2 takes 10. Okay, it's different, still different. 3 takes 20, 30, still different. 20, 10, 30, different numbers. 4 takes 20, is not the same. So the 1 takes 20, 4 takes 20 is the same like the number 1. Again, 1 takes 20, okay. 2 takes 10, so it's still different. The 20 and 10 are different. 3 takes 30, still different. Look, 20, 10, 30 is not the same. 4 takes 20. Oh, the 20 is the same as 20 here. So the 1 takes 20 and 4 takes 20. So this is mean the function is not one-to-one. Correct, Bilal? Ryan, correct? So the function here, so the function g is not one-to-one function. Again, why? Because the 1 takes 20. As we see here, the 1 takes 20 and the 4 also takes 20. So this is making a short, we cannot like make, this is not one-to-one function. It's not one-to-one function. The 1 takes 20, the 4 takes 20, the same element. So this function is not one-to-one. Any question for the one-to-one function? Any question? So it's clear now how I can define the one-to-one function. So this is like the general idea. What does the mean of one-to-one? Now, sometimes I will give like in the exam some functions like g of x equal, for example, x squared, or f of x equal x cubed plus 1. And then I'm going to ask you, is the function is one-to-one? So this diagram and this diagram just to show you the general idea what is the mean of the function one-to-one. Now we're going to solve or to do like some tests to check if this function, like the written function, is one-to-one or not. So to check the function is one-to-one, I'm going to give you like two and direct property, easy and fast, to check if the function is one-to-one or not. So here write to check the function is one-to-one by two things. First one, by the definition. By the definition. So the definition said if f of x1, to check the function f here, is one-to-one, we have to, like there's two options. By the definition, f of x1, if f of x1 equal f of x2, then x1 equal x2. I'm going to explain this by the example. And the second thing is by using the horizontal line test. By using the horizontal line test. Okay, this test said I'm going to graph a test. I'm going to graph a horizontal line on the curve. If this line intersect the curve at only one point, this is mean the function is one-to-one. But if this line, the horizontal line, intersect the curve at two or more points, this is mean the function is not one-to-one. So let me here explain, give you the definition, what is the mean of horizontal line test. And also I'm going to explain this by the example. So the function here I can say if no horizontal line intersect the graph more than once. Okay, this is very important property and rule. We should use it to check if the function is one-to-one. So the definition, by using the definition, f of x1 equal f of x2, then we have to check is x1 equal to x2, or by using the horizontal line test. If no horizontal line intersect the graph more than once. Okay, let me give you example for how we can use this property. So here the example is by using the horizontal line test. So by using the horizontal line test, here in this question, I give you the option, the way how to check. So by using the horizontal line test, so number one, is the function f of x equal x cubed one-to-one. Second one, is the function the same thing, but here we don't have to use We're going to change the function. Number 2 is the function x squared is 1 to 1. So here for the first one is x cubed. Here we have x squared. Okay, so first of all, to use the horizontal line test, we have to graph the first function. By the way, this is a very important question. This is a very important question. You should to know how you can use the horizontal line test to check if the function is 1 to 1 or not. So the graph of the function of x equal x cubed, as we learned last time in the beginning of section 2.6, is look like a function like this. Okay, this is the function f of x equal x cubed. This is f of x equal x cubed. Now we should to check if this function is horizontal or not, if this function is 1 to 1 or not. So first of all, we have to graph a line like this, and we have to check if this line intersects the curve at only 1 point or not. Okay, look, if I want to move this line, the green line, above of the function of x equal to x cubed for all values of x, I will see that the line, the horizontal line, intersect the curve at only 1 point. Do you see? Again, the horizontal line intersect the curve at only 1 point. So this is mean the function is 1 to 1. Okay? So here intersect at only 1 point. So it's 1 to 1. So passing the horizontal line test. So the function is 1 to 1. Who will do the second one? How is the graph of the x squared? How is the graph of the function x squared?
The function x squared would look like kind of like a parabola.
Yes, correct.
That means that if you were to pass a horizontal line, it would intersect at 2 points in the same graph. So it would not be 1 to 1.
Okay, nice. This is correct too. So the graph of the second function, f of x equal x squared, it's look like a parabola. So this is number 2. The graph of the second function is a parabola like this. This is the function. This is f of x equal x squared. Now to check the horizontal line test, we have to graph a line, horizontal line. And as we see here, if we moving this line above the curve, the red curve, we're going to say this line intersect the curve at 2 points. This is the first point, and this is my second point. Same thing here. If we move it up, they will intersect at 2 points. And at every point in the domain, the line intersect the curve at 2 points. So because the line intersect the curve at 2 points, this is mean the function is not 1 to 1. So f of x, the function. So the function f of x equals x squared is not one-to-one, is not one-to-one function. Is it clear? Any question for this? Okay, the last thing here, how we can use the function, how you can use the definition to check if the function is one-to-one. So right now in this example, we use the second way to check if the function is one-to-one. We're using the second way how to check, how to see if the function is one-to-one. Now I'm going to use the first one, the definition, to check if this function is one-to-one or not. Is it clear, this one, the example? Any question? No questions. Okay, so now let me give you example. So example for how we can check the function is one-to-one by using the definition. So the question is, by using the definition, the definition is given f of x1 equal f of x2, then x1 equal x2. So here, if the function, this is equal, then x1 equal x2. Show the function. The question is, show here, show the function f of x equal 3x plus 4 is one-to-one function. So the example would be the same like this. So by using the definition, if f of x1 equal f of x2, then x1 equal x2, show the function f of x equal 3x plus 4 is one-to-one function. So to do this one, you have to write this thing, f of x1 equal f of x2, then you have to plug the x1 inside the function, you plug the x2 inside the function, you have to simplify this thing until you get x1 equal x2. If you get this thing, this is mean the function is one-to-one. Again, to solve something like this, you have to write f of x1 equal f of x2, then you have to plug the x1 inside the function, you plug the x2 inside the function, then you have to simplify whatever you get until you have to check x1 equal x2. If you get this thing, x1 equal x2, this is mean the function is one-to-one. Okay, let's doing together. Okay, so f of x1 equal f of x2. What is f of x1 after you plug it inside the function? Plug the x1 inside this function. You're going to get what? 3x1 plus 4 equal to what? Plug the x2 inside the function here. you're going to get 3 of x2 plus 4. So just you have to use this definition. It's not hard. Just use this definition to check the function is 1-to-1. Okay, so f of x1 equal f of x2. We plug x1 inside the function, you get this thing. We plug x2 inside the function, you get this thing. Now let's simplifying the left side and right side. Here we have 3x1 plus 4 equal 3x2 plus 4. We can cancel the 4 with the 4 by subtracting 4 from both sides. This cancel out, this cancel out. Now I get 3x1 equal 3x2. How we can cancel the 3 from both sides?
Divide 3 on both sides.
Yes, we have to divide 3 for both sides. So this cancel out, this cancel out, I get 1. So I get x1 equal x2. So this is mean when I get x1 equal x2, this is mean the function f is 1-to-1 because I start from x1, f of x1 equal f of x2. I like doing cancellation and I cancel and I subtract until I get this thing. When I get this thing, this is mean the function is 1-to-1. So f of x equal 3x plus 4 is 1-to-1 function. Okay, any question? Any question for this? Okay, so we're going to see you Thursday. Have a good day, everyone. I mean Wednesday. See you Wednesday. Have a good day.
Have a good day, Chris.
You too.
Professor.
Have a good day.